understand SHM, that is simple harmonic motion, that is also known by the topic oscillations. This is called simple harmonic motion because this motion can be expressed by a single harmonic simple function like sine and cosine. Before we proceed into this, let's understand some of the terms which we shall be using repeatedly in simple harmonic motion. That is, the first thing is periodic motion. That is, what is periodic motion? Periodic motion is a motion which repeats itself after a fixed interval of time. Like Earth is revolving about its own axis, so this is periodic motion. Earth is also revolving around Sun also, so that is also periodic motion. The movement of hands of a watch, that is also periodic motion. And then we have oscillatory motion. In oscillatory motion, our body is moving to and fro about a fixed mean position. So like the motion of a pendulum about its mean position, that is oscillatory motion. Or, so on a horizontal frictionless surface, if this is a block of mass m attached to this wall with a spring of spring constant k, and it is slightly pulled this way and released, then the kind of motion it executes, that is also oscillatory motion. The thing to note is that oscillatory motion is a periodic motion, whereas periodic motion may not be oscillatory motion. It is not necessary that is all the periodic motions they are oscillatory motions, but all the oscillatory motions they are periodic motions. When we talk of the simple harmonic motion or SHM, so this is also oscillatory motion. But one thing is that this motion can be expressed by a single simple harmonic function, that is sine or cosine. We can also have a complex harmonic motion which is superposition of many simple harmonic motions. So now when we talk the time period is the shortest time interval after which the motion repeats itself. Like over here, if we see that is this is a frictionless surface, horizontal surface, and over here this is a spring with spring constant k, and this mass is tied to this spring and it is slightly displaced from its mean position. So this is the mean position. It is displaced from here, so we pull it over here, then release it. So we know that this will be oscillating like this. This will be oscillating like this. When it is oscillating, so all the time it takes to reach from here to here, then comes back, then comes over here. During this time, that is this time when it reaches from here to here, then from here to here, then from here to here, this is the time period. Once it reaches this, after this is once again the repetition of the same motion. So this is the time it takes from here to here, from here to here, and from here to here. So this total time is the time period. We can start from the mean position. We can also start from the extreme position also. Let's say when it reaches over here, then it goes over here, then it goes over here, and once again now the motion is repeated. So this is also time period denoted by capital T. So whatsoever this time, the same is this time. You can start from anywhere. Even if we wish to start from this position when it is going from here to here, so it goes from here to here, then comes from here to here, and then reaches back over here. So this is also time period. This time period, this time period, this time period is absolutely the same period of time. So time period is the shortest time interval after which the motion repeats itself. And then comes a frequency. What is frequency? Frequency is the number of oscillations in 1 second. Frequency, or we say linear frequency. It is denoted by nu. If the time period is denoted by capital T, so number of oscillations per second is going to be 1 by T, and this is called linear frequency. Unit is hertz, written as Hz, or cycles per second, or per second. It is linear frequency. We also have angular frequency. We will come to that. So linear frequency is number of oscillations per second. So this comes out to be 1 over time period. So if time period is half second, so it means in half second 1 revolution is completed. How many revolutions will be completed in 1 second? That is obviously 2 revolutions. For every 1 revolution it takes half second. So number of revolutions is 2 revolutions per second. So over here if we say frequency is equal to 1 by T is equal to 1 upon 1 by 2, that is 2 cycles per second or hertz. So this is going to be the frequency. Then comes amplitude. Amplitude is the maximum displacement from the mean position. It could be on either of the sides. So that is, if this is the mean position, this is MP stands for mean position. So the body is going from here to here. So this is one extreme. So this is also amplitude. From here to here it goes. This is the other extreme. So this is also amplitude. Amplitude is the maximum displacement from the mean position.